Hello, my name is Andrew Grigsby, and I'm a home energy rater. And we're here at the Forest Lakes Community Center to do an energy audit. And we're using a public building here, but this building is really just sort of an enlarged house. So we're going to start our energy audit with thermal photography with an infrared camera, which is really an X-ray machine for your house. It's telling us where there's heat loss. That's money that's slowly filtering through the wall. So we use this to diagnose how the insulation is performing and where there are spots that might need more insulation. Well, we're starting here on the outside of the building using the infrared camera to try and find some weak spots in what we call the thermal envelope of the building, basically the shell, the part you insulate, the walls. And looking at this house here, what the problem area I see is down here, the foundation. This area is showing up hot. Means it's not well insulated. Obviously on the outside we can see here that it's concrete. We know concrete conducts heat readily, so we're hoping there's insulation on the other side, but clearly if there is insulation, it's not performing well. Outside we're looking for hot spots because that's where the heat is coming through. Inside we're looking for cold spots because that's where the cold is coming through, again on this chilly spring morning. So we're looking over in the corner of the room here, or we see a cold spot in this corner. Also, up above, well, the very corner of the wall is showing up as very cold. And that's typical because when this building was built about 15, 20 years ago, we often left those corners uninsulated, or we built our corner out of all wood, which is not the best insulator. So it's showing some very typical problems. But the little surprise is up above it. In that little bit of slope, we can see it almost looks like there's some, assuming that this is insulated with batt insulation, it looks like there's some batts missing right in here and right in here. That's the beauty of this camera, is you find those places, because otherwise you'd never know. You'd look at that wall and say, and assume, well, it's probably doing fine. What's showing up in this wall here is most of the wall is nice and orange, showing it as fairly warm, and then there's one tall blue line going through here. And what that's telling us is that between those two studs, it's a stud bay, basically without insulation. There's also cold spots showing up right at the baseboard. What this is sort of the mirror image of what we saw outside with that cold masonry foundation. It's that area. It's also what we call the band joist area, where the floor joists under us intersect the perimeter of the house. That's an area that tends to be poorly insulated. The camera allows us to save images. It's just like a regular camera. It's really amazing. And we can save these images, download them to the computer, and show them to the client later. It really shows them, here's where some insulation is missing. Here's some areas you need to think about if you want to lower your utility bills. Here we have the blower door. And what this is a set of equipment, including a fan and a screen and a gauge, to basically measure the draftiness of the house, to depressurize or pressurize the house to a certain pressure that's an industry standard, and then based on the amount of air it's moving, that tells us how much air is coming in through the random leaks and cracks all over the house. This is just a big fan. It's got pressure gauges in it, and we are going to start sucking the air out of the house. And because our framing system isn't airtight, anytime we go through the floor or go through the drywall, anytime we go through the paint layer, you access sort of the cavities of the skeleton of the house. And all those cavities conduct right to the outside. They have open spaces that go to air leaks. And so that fan is pulling air from the outside through the floor framing up through this hole. That's why whenever you, where that plumbing penetrates the subfloor, it should have been sealed with caulk or foam. Well, we have the results of the blower door test. Remember earlier we got a number of fan flow. We have to compare that to essentially the size of the building, and we use the volume of the building, cubic feet. And the number we get is 7.8. which is a measure of air changes per hour at the pressure point that we used. And 7.8 is actually a pretty good score. It's a fairly tight building, but still lots of things that we can do to make it tighter and save a lot of money. We are going to do a duct blaster test. And what we do is first we pressurize the house, and then we pressurize the duct system against it. And the number we get is the airflow, the leakage of the duct system to outside. And as I mentioned, this is a big problem. They estimate that duct leakage in the U.S. in residences is on average greater than 15%. Again, that means the air that your air handler, your furnace, that you think is blowing in your house, 15% of it, it's just blowing to the outside, along with your money. So we've set up the blower door again. We're going to cut it on and pressurize the house to 25 pascals. We've gone through the whole house and covered all the registers with this plastic duct mask. So we've sealed off all the registers and basically isolated the duct system. So it's now theoretically a closed balloon, and we're going to blow air into it and see how much air is leaking out, which is what we don't want. Now this is the duct blaster, which is again a fan with sensors in it. It's basically a smaller version of the blower door. We're now going to blow air into the duct system, and since we've covered up all the registers, none of the air is escaping back into the house. And any extra air that gets through it past that 25 pascal point to which we've pressurized the house, we know that's leakage to the outside. That's dollars being thrown away. So we got a pretty bad score on the duct leakage, 600 cubic feet per minute. And we take that number and use it as a ratio compared to the floor area served. And the first floor of this house is about 2,000 square feet. 600 over 2,000 equals 0.3, 30% duct leakage. That's terrible. That's a lot of money going right out the window. So now what we're going to do is go downstairs and try and find where some of these leaks are. All the duct work that serves the first floor of this house is down here in an unfinished, unconditioned basement. So we're outside. We're outside of the thermal envelope of the house. And that fan upstairs is pumping air, a lot of air, into this duct system. And it's escaping somewhere in great quantities. And I hear a little leak over here, but you can't see the smoke, but you saw that thing glow. There's a lot of air coming out right here where the filter goes. So this is a pretty imperfect design for the filter. This is not part of the duct system. This is not, leaks here don't matter, so the big holes in here don't matter. But behind this panel is the fan and the duct system. And this panel really should be a lot more airtight. So if you imagine when that there's the fan moving, and as it's blowing air into the house, some of it is just blowing through the leaks around this panel. But here we have duct boots and insulated floor. And what's happening is I fill the duct system. Some of the air just came up and went back down through this crack. So all these cracks are air that can be pushed to the outside. What I'm going to recommend to this homeowner is that they actually hire a professional company to come in. They can use what's called a flow hood and test the output at each duct, at each register. That tells you which ones are getting less air than they ought to, and then maybe there's a leak along that line. That'll help identify the problem. They'll seal all the boots to the finished surface. They'll do some work on the air handler and hopefully really knock down some of this leakage. Again, my name's Andrew Grigsby. I'm a certified home energy rater. There's probably one in your neighborhood. Go to the website of ResNet, which is a national association related to home energy raters, certified home energy raters. Get an energy audit, learn something about building science, learn about the opportunities in your house to save money and save some energy. Thanks.